Belzona's HVAC solutions. Repair and protection for different types of HVAC systems, looking at ductwork, chillers, cooling towers, and air handling equipment as well. These are cost effective. Why not extend it? Protect these necessary and expensive systems, as well as minimal downtime, or if any at all. As you can see, we're going to cover some condenser water systems, the chilled water systems, air handling unit, and ductwork.
Oh, dude, that's amazing. You know, obviously with an intricate part like this, there are little small gaps in space.
All right. Proven solutions for the HVAC systems through Belzona. You know, corrosion is usually the major battle for building owners and managers to maintain the integrity of an HVAC unit. If the issue is left untreated, there's probably a high probability of environmental and safety hazards, incidents, and high replacement costs. You know, if not properly treated, metals gradually self-destruct when exposed to air, water, or even other metals. This is the process of corrosion, which is a serious problem in heating and air conditioning systems. Corrosion and its deposited byproducts can reduce equipment efficiency, increase operating costs, and cause equipment failure. Most concerning is how to reduce the likelihood of this event in the long term. Represents a major challenge for most people in these industries that have to oversee these types of systems. Problems can cause inefficient heat transfer, higher energy costs, reduced reliability, damage to equipment, and increased risk to the health of the occupants. You know, what is the problem? Corrosion. We're going to look at a couple of them. What are these main problems? You know, condensation weakens and corrodes the metal surfaces, leads to breakdowns in the structure and subsequent structural of the HVAC system and operational failure. Water temperatures is something to consider. Chemical reactions proceed faster in hot water, as we know. As the water heats up, more oxygen reacts with the electrons and waters at the cathodes, forming hydroxides. You know, usually a rule of thumb is 18, you know, anywhere between 18 degrees Fahrenheit, you're going to get increased temperature for this type of damage. Water pH, the pH in untreated water drops. Corrosion tends to increase. The lower pH also dissolves various oxides and exposes more of the metal surface to corrosion. You know, aggressive cleaning agents that are used to clean these types of systems. The water treatment chemicals used to prevent scale and fouling accelerant corrosion rates. They lead to perforations and holes and severe metal loss on units and services. Deposits. Low water velocity allows solids to settle and deposit on the metal surfaces. These deposits make it impossible for any corrosion fighting chemical to do their job. Protective film provided by the corrosion inhibitor settles on the deposit rather than on a metal surface, which we will cover. As a result, localized corrosion can thrive unchecked underneath these deposits. Galvanic corrosion. Usually there's two different types of metals in these systems. And as we know, the two different types of metals are connected. The exposed moisture or water corrosion can occur. Microbial CUI as well. Other problems in HVAC systems include stuff like your cooling tower fans. Cooling tower fan blades usually suffer from erosion on the leading edge, as well as cracks and flaking on the edges, reducing the overall efficiency of the cooling system, ultimately leading to failure. Ductwork, you know, whether through active operation or natural convection, can develop rust due to water content in the air. Condensation weakens and corrodes the metal of these ducts, which can lead to a breakdown in the structure and subsequent structural and operational failure. Rust buildup can also lead to secondary problems such as mold, introduction of harmful particulates into the ventilation system, providing health issues for the occupants. Mechanical elements with close tolerances such as shafts are susceptible to wear at accelerated rates, particularly when exposed to corrosion or dust and fine particles that will get in there. Why Belzona? You know, HVAC engineers illustrate how Belzona has been able to provide an alternative, cost-effective, and long-lasting option compared to conventional alternatives. Belzona materials combine easy and safe application with outstanding mechanical properties. The versatile product range provides varied working times, cure times, temperature ranges, and degree of surface preparation required. So that's something to consider depending on what your scenario is. Belzona has a track record of solving these maintenance solutions, and I'd like to illustrate this, how we together can solve these problems. You know, we have our 1000 series. These are for your metal repairs and protection. Our 3000 series for sealing and encapsulating. And the 5000 series, your coatings. This is going to prevent any of the corrosion and environmental problems that you're going to experience, as well as the repairs that we would do. This is going to give that extra layer of protection and seal it in. Start here with some cooling water channel heads. These are pretty large, but you know, just to illustrate, 28 sets of channel heads with end covers sent to us at our facility in Alvin. Something to also consider when it needs to be brought off property. Our facility in Alvin, Texas is utilized for a majority of repairs like this that can't be done in the field. We do work with other shops. Some of these can also be done in situ on the location. But something with our Alvin facility, your budget and time as to when it needs to be back into service is absolutely our highest priority. So as you can see, there's 28 of these sets of channel heads with end covers. We're averaging about 3 to 4 sets a day. Once repaired, as you can see in here, any kind of metal loss, pitting, we're going to rebuild those with some of our paste composites. And then we're going to provide a protective coating over the top, 2-layered system. When we're averaging 3 to 4 sets of these a day, we're able to turn around this very quickly for our clients. Here's a final picture of it with that second coating. Cooling towers. We're going to look at some cooling towers here. Seal the seams in. Pans. And using a final coating to protect all of the work that's done and to give you that long-term solution. Chemicals used in the water treatment had eaten through some of the galvanized on the sheet metal here. Pans needed to have the seams sealed and pans coated to prevent further corrosion. Typically, we're going to go in, we're going to use some abrasive blasting on these pans prior where the seams were sealed. Internal surfaces, something else to think about on some more cooling towers, be it large or small. I'd like to show these as some examples of things that you'll typically see when you're inspecting these types. Concrete basins can be affected too by all the processes we mentioned. You know, weather temps fluctuating as well as vibration. In here with some of our 4000 concrete series products, you can see the before. Here's the damage. We've got cracked and spalling. Second picture, this is going to be where we come in and prep, and then we provide our 4000 series to rebuild, seal in these cracks and spalling. And then third picture is the ultimate finished product with a coating that's going to seal that in and give you that long-lasting, permanent type repair. Here's a recent cooling tower project on a building in Houston, some commercial buildings. We're going to look at here is some of our flexible membrane systems, as well as coatings that are used to protect. And our 1000 series for rebuilding stuff in here, some of this pitting and metal damage that you'll see, and also prevent any kind of leakage that's happening due to corrosion. (1121) used to come in, fill in all that metal loss and damage, and then apply 2 coats of the 5811, as you can see, to protect that repair, as well as any kind of outside environmental elements that are going to damage this. This is 3 years ago this was done. From that original slide, here's your finished project. Cost effective, done in a timely fashion, not having to remove from the building, not have to set up a crane. Could all be done in situ. You know, why not seal in on leaks on some of your externals? You know, leaks can lead to other damage, as they call the downhill effect. This can ultimately damage structural elements, your roof, or even get inside, causing internal damage and water damage to inside the facility. These membranes, this 3100, this is a flexible membrane. So it's going to breathe and move, as well as fluctuate with the hot and cold, and not damage any of the properties. CUI repairs on a chiller. This is one we like to show because, as I just said, you'd have to remove this. How are you going to remove this? You're going to have to take a wall out. Probably going to have to block off a street and get a crane to do that. Why not do this while it's in situ and do it with minimal downtime? And when I say minimal downtime, this is the type of project that's actually done in backup and running within the same day. This is also a 50-year-old train chiller. It's located on the 5th floor of an office building. So we use some of our quick cure 1212 to rebuild this metal loss and the damage, and then provide a coating over the top just to repair that and also protect it because it's localized. This is where we know in the future it's still going to happen. Very cost effective than replacing this and all the factors that have to go into replacing something like this system. Corroded end covers on a chiller unit. Some of those more smaller type applications, you have to protect these. Here's your before, here's your after. Most would actually kick this off to the curb and wait for some kind of delivery time. And that's another thing to take into account, logistics. Where is it getting shipped from? It's coming from overseas. We're seeing a lot right now are not able to predict an accurate timeline as to when you'll get this. And you've got your people inside that are going to be suffering from some crazy environmental type temperatures. Why not just refurbish it, repair it, and protect it? Again, I'm going to use that word, cost effective, but that's exactly what it is, and minimal downtime. Stuff like this, I like to show the infrastructure that's holding it up. This collapse, this whole system goes down. So as you can see, we're going to prep this. Various types of methods you can use with hand tools, also aggressive blasting, as well as vapor blasting techniques. Once we get this metal down to bare metal and get to some good metal, that's pretty much all we need. We're going to go ahead and we're going to repair it and then coat it before and after. When you're looking at this, the corrosion on these floor joints would have caused this to eventually fail. And you'd have to shut this whole facility down. This was actually for a retirement community that we're looking at. A lot of liability if this goes down for a retirement community. Pumps. Pumps shift a lot of the fluid around in these systems. Like to highlight this because there will be some metal loss and damage. Be expensive. Also, again, lots of downtime when replacing a pump. Why not rebuild it wherever the metal loss is? And then coat it. And then by coating it with certain products like a 1341, you create a more efficient pump. There's also been some studies shown that by creating more efficiency in these pumps, you're able to decrease the cost of your energy bill. Some of the internals that like to move these fluids in our HVAC systems can be rebuilt and ultimately coated. So with cooling water pipes, some of the stuff like pipes that will move to smaller to larger type HVAC systems can spring leaks, live leaks. This is that downhill effect I had mentioned earlier. This live leak, if this is on top of a roof, I'm sure that we can all know that it's going to create some damage probably internally into the facility as well as on the roofing elements. But with our live leak repair, you come in and you can stop this leak live very quickly. Once it's plugged, you're going to come around and rebuild the protective shell around it. You can also use traditional wraps and composite wraps for these types of repairs. So our next slide will go into a leak that's repaired and then used with an ASME engineered compliant wrap system. This is pretty damaged, heavy corrosion and erosion. If you are needing an ASME compliant system, we have our own internal engineering team that will get these calculations done for you. They come up with the exact solution and provide all the technical data, the work scope, and exact calculations and documentation. This is a true permanent solution. As it says in the slide, it's designed for 20-year. So we're going to come on to fan blades. Fan blades are getting very popular now on the repair and refurbishment side. That is usually typically due to your logistics. How long are we going to get one? We don't know. It's coming from overseas. Also seeing some of these fan blade manufacturers aren't in business anymore. Do you replace an alternative fan blade with something that it's not designed for? So as we look in this graph, there's our fan blade splinting. With Belzona's latest polymer technology, FRP fan blades can recover and be repaired. We can provide that edge strength by applying a Belzona ceramic polymer. Then protect from erosion and corrosion and UV rays with a Belzona ceramic coating system. So in this diagram, this is what you'll typically see, erosion on the fan blades. Here we are with some surface preparation. We're also going to use either an MEK or a Belzona 911 cleaner degreaser. Get rid of any oil or grease and contamination on this surface prior to doing this type of prep. And you're seeing the application of 1121, which is a typical product that we'll use to rebuild, especially on metal fan blades. And here we are. We could use a 9341 reinforcement tape on it. An epoxy resin combined, just give it that extra strength. You have a complete rebuilt fan system. Some other pictures of some fans. You can see suffering from some severe damage on the edges, starting to lose some of its structural integrity as well. We'll come in, we're going to prep these fan blades, rebuild where we need to, and then coat the entire system. Metal fan blades as well. These can be the ones that get very, very expensive. Here they are coming into us at the shop, starting the process of the repair and refurbishment, and then your finished product. So we use a couple series of different products and fan blades to give you that complete system and protection. We're going to move on to some tube sheets and the chillers as well. Chillers are a vital part of any heating or air conditioning system. You know, failure to quickly protect these units allows galvanic corrosion to take place, ultimately resulting in wastage and metal loss on the tube sheet around the coolant tubes. Left untreated, the loss of metal can cause leakage of the coolant and contamination of the chilled water. So a corrosion allowance is designed to accept anticipated levels of metal loss. However, throughout the lifetime, the metal loss will gradually occur, primarily due to galvanic corrosion. If the corrosion allowance is exceeded and gaps appear, recirculation can occur, leading to efficiency loss. As well as the processed fluid can erode the metal further, accelerating degradation if corrosion is already present. The affected section is always going to be rebuilt using Belzona's 2-component repair composites. It's a paste grade material that rebuilds the substrate to its original tolerance. So here we are looking at that damage over time. This is where we come in with the paste grade, the 2-component repair composites, going to be rebuilt. Metal loss rebuilding, build that back up to its original profile. And then put on some erosion corrosion protection final coated layer. Now this is achieved, as you can see, we have to get surface prep as everything. So what we're going to do is put some corks inside your tubes to prevent it from getting any media in it while we're blasting. Once we achieve the proper surface, we're going to rebuild with our paste grades, as you can see right here. And we will rebuild this typically up to where the tubes are sticking out. So you're going to get that extra layer of sacrificial metal in there. And then a complete application is always going to be to coat and protect the repair, as well as give you that long-term protection. Severe corrosion on these tube sheets. As I said, we're going to put these corks inside your tubes. We're going to get our blasting techniques, or however we're going to achieve this surface prep. Protect it. Here's your bare metal. And then we're going to build it up. You notice there's no specialized real tools doing this, except for typically the blasting process. And then the complete system. So in this next slide, we can see, this is a good example. This is a chiller tube sheet that was suffering from corrosion due to a galvanic corrosion. The surface was prepared again by grit blasting, washed with Belzona 911 to remove all residual blasting debris. The tubes were plugged, as we mentioned, with corks. And Belzona 1111, pretty popular product of ours, was applied to the area using this applicator. The 2-coat Belzona system with 1321 was also applied. This offers protection against the effects of erosion and corrosion, and it's going to have outstanding resistance to any kind of chemical attack. Air handling systems. So there's a lot of solutions we can provide on these as well. As you can see in our diagram, this is your typical air handling system. You know, anywhere from internal corrosion accelerated by water condensation, high temperatures, aggressive cleaning chemicals, and microbiological growth. This will cause failure of the joints and seams. Maintenance of the air handlers and ductwork can prove to be challenging, depending on where they are as well. Condensation weakens and corrodes the metal of these ducts. Here's where your corrosion is going to start to show. Surface prep. Need good metal to bond to, as well as clean it from any type of debris that we've created from it. And as you can see here, where it's repaired, we're going to come back in with the second coating system. And also we have joint sealing. We're going to seal in those joints. Do a complete system. After you've repaired it, protected it, sealed it in, you just know how to repair and refurbish complete ductwork system. Some pictures on some ductwork. You know, Belzona elastomer products for hard to find expensive gaskets and seals will be used. Outlets on roof. The effects of weather and UV will cause a lot of these rubber seals to degrade and eventually deteriorate over time, ultimately allowing typically rainwater to leak directly into these. These membrane systems, the 3000 series, are flexible and designed to breathe and move too. So with heat fluctuations, cold, hot, you're not going to lose any of the mechanical bonding and the strength that it's designed for. Schools and universities, hospitals, commercial buildings, all very, very important that these HVAC systems stay working. And here, you have heated and cooled air rooftop ducts. So the original protection that typically comes along with these systems when they're first built, they're no longer, after time, they're not going to be watertight. The insulation will get wet. Water starts to leak in through there. Also will leak into the building. CUI is another typical scenario you're going to start to see develop underneath this insulation. We can do, you don't have to remove all of this insulation. What you can do is you can use a Belzona system that can go over this existing, that's microporous. So the Belzona system that we're going to apply over the top of your already existing insulation, it's going to allow that moisture to leave when I say microporous, while preventing any other moisture or outside environmental elements from coming back in and damaging it. 3 years ago, this was applied and still working. Shafts are pretty popular in HVAC systems. They do get damaged. Bearing sides for air handling equipment. So in this one, what we're seeing is one of the bearings. This is on an office building on the air handler system. It failed due to severely gouged, as you can see, damage into the shaft, the fan's shaft. The cooling system was pretty much nearly crippled, triple-digit weather. So you're going to use a 9411 to prep this shaft, degrease it, get rid of any oil or any kind of contaminants. Different types of paste grade solutions can be selected depending on what the scenario is. Time, cure times, how fast you need it back up and running. And then what we do is we can fabricate a clamp. This clamp is placed over the shaft. And once that clamp is in, we're going to apply the paste grade material and let it cure. So this was done in the morning, and by 8 a.m. back up and running. So you're looking at 2 to 3 hours is when it was completed. So get there early, get it done before anybody enters the facility. This is back up and running, allowing for the proper application for what it's designed to do. And then finally, leaks on hair handler joints. Pretty typical problem out there. Seal this in. When you want to seal this in, using something like Belzona, it's not going to be like your Home Depot type product that you're going to go out and use. It's going to give you about a year or two, maybe less than that. When thinking about something like this, think about return on investment. We want long term. Once this is applied, this is going to give you that 10+ year. So we had a lot of late joiners in here. This actually concludes the webinar. If you can, in that comment section, please provide